Hi, so today I'll be going over some of the changes we've made to the soen385 final project graphical application. So what we've done is we've added some fields here that let you control the PID controller parameters for the PID controller equation. And that equation is actually what's stabilizing our system response here. So what we'll do today is I'll just go over the changes on the interface and then we'll dive into the code and we'll have a look at that. So in the interface here we have a new controls section with a title of PID controller parameters. In this section you can change the three parameters of the PID controller, which are KP, KD, and KI. All you have to do to change these fields is simply modify the field and then click out of the text field of the box, and the equation for the controller will automatically be adjusted and applied to our system. So I can demo changing a few of these parameters here, and the output will be seen in the system response. Now it may take a second or two to adjust here, especially now that I'm recording, but eventually when the charts adjust we can see what the system will look like if we use these values as our PID controller. So what does this look like in the code? What we've done in the code here is what we're doing now is instead of taking the PID controller equation from PID tune, so instead of taking it directly from MATLAB, we're actually taking these as input parameters. And in the equation that adjusts our graphs, what we're going to do is we're going to grab the values for the PID controller. We'll compute the initial transfer function. So this is the transfer function that is uncontrolled. And in fact, this transfer function will not result in a stable system response. So if we have a look at this equation without applying the PID controller, it will be unstable at this point, and the charts will go on to infinity or what have you. They will not be stabilized. After we compute the initial transfer function, we'll calculate the equation for the PID controller using the PID MATLAB function. And then how we actually insert the controller in the system is we apply it in series with the uncontrolled system transfer function, and that's going to give us a new transfer function, which is the product of the PID controller equation and the uncontrolled transfer function of the system. But we're not done there. We actually have to add a unity feedback in order to create a closed system. So this is basically how you create your closed loop PID controlled final version of our transfer function. And once we set that value, we're just going to compute what the actual equation is, and we'll display that in our latex figure over here. So this is what the actual equation will be computed as. And then what we'll do is just plot that system as an impulse. We'll plot the response of the system to impulse, and we'll plot it to a step input. So those are the changes that we've made. Thank you for watching this video, and I'll see you later.